In the previous examples, we made it a point for you to find the x or the y value that had a coefficient of 1 or -1. And so you can see here, this is going to help us choose the method that we want to solve the system of equations with. And so you can see that in the first example we had an x that had a coefficient of 1. In the second example we had a y that had a coefficient of -1. And so both of these were easily used for substitution. Now, if we get an example that actually does not have a coefficient of 1 or -1, then what we're going to want to do is we're going to move on to the linear combination method. Now, the linear combination method has been referred to as the elimination method informally in a lot of textbooks, and a lot of teachers use that language. So be aware that if your teacher uses linear combination or elimination, that they basically mean the same thing. And so let's take a look at what we're going to be doing here in linear combination. Basically, if we look at example number 2, we'll follow the steps in example number 2. What we basically are looking to do is to stack these equations on top of each other. But what we're hoping to do is to create a situation where one of the variables, either the x or the y, has an opposite from each other so that we can combine the terms together so that they eliminate each other, and that's where the word elimination comes from. So the very first thing we're going to look to do is to see, can we multiply one of the equations by a value that would end up creating this offsetting value. And so if you look at it, we have 2x and we have a 4x. So I got to think to myself, is there anything I can multiply to 2x that would give me -4x? Because I want it to be the exact opposite of the 4x. And so I can multiply that by -2. Now, here's the thing. It's like the distributive property in a way. If I'm going to multiply the 2x times -2, I have to multiply the entire first equation by -2. And when I do that, I get this new equation. I get -4x plus 8y equals -26. Then I'm just going to rewrite equation 2. And so I'm going to do this in a stacked method. And so basically I'm going to add or subtract up and down. So at this point I'm combining like terms. So if you look at step 2, it says to combine the like terms. So I know that 4x and -4x actually cancel each other out. They give you a 0x. 8y and -5y gives us 3y, and -26 and a +8 gives us -18. So now I simply have this equation 3y equals -18. And I can solve for y. So y equals -6. So I've used this elimination process to come up with my y value. Now the interesting thing about here is this is technically elimination. Once I've got it down to a variable, y equals a certain value, we're actually going to use the substitution process to get on the back end of this. And so you can see here in the third step, we're going to use substitution by taking the -6 from the previous one of y and replacing the y with -6 so that we can come up with our x value. And of course, once I have an x value and a y value, I can set those together as an ordered pair. So that is your brief example on using linear combination, or informally known as elimination method, to come up with the solution for this system of equations. So what I'd like you to do is go ahead and stop right now and work on sample problem number 2, part A and B, and try to figure out how to use the linear combination method to solve these systems of equations.